We're seeing the highest density in this sector.
Yes, the magnetic anomalies are strongest there.
All right, let's mark this as the primary target for extraction.
The iron content here is high, almost 60%. But look at the moisture levels in this section.
Noted. We'll need to adjust the processing estimate.
Modern steel begins long before the furnace, buried inside mapped layers of iron-rich rock. Before mining starts, every layer is tested for quality, depth, and economic value. Digital mine planning decides exactly where steel's raw material will come from. The mountain is reshaped into a working mine before a single truck is loaded.
Every blast is engineered to free ore safely, evenly, and at massive scale.
Precise blast patterns are what turn solid ore into something a mine can move. Size reduction is the first step in turning raw rock into processable iron feed. Even after blending, the ore is tested again before concentration starts. Once the blast settles, the mine starts sorting value from waste, one bucket at a time. The first machine in the chain breaks mine rock down into crusher-ready feed. The plant sorts ore by size, so each next step works faster and cleaner. Hours of intense heating turn coal into the hard carbon skeleton the furnace needs. Quenching locks the coke into a stable form for storage and furnace use. With one controlled detonation, millions of years of geology break open for industry. Coke ovens heat coal in the absence of oxygen to drive off everything but carbon-rich structure. The blast furnace depends on superheated air supplied by its towering stoves. Once crushed and sized, the ore moves by conveyor into the heart of the plant. Steel needs more than ore. It also needs special coal that can become blast furnace coke. The freshly blasted ore begins its long trip from pit floor to steel mill. Grinding frees the valuable iron minerals from the surrounding waste rock. Limestone helps pull the ore's unwanted minerals into a separate molten slag. No single coal does the whole job, so producers blend several types together. A foamy slag forms to capture impurities as the converter refines the melt. Because the concentrate is so fine, binders are added before pellet formation. Fresh coke leaves the ovens red hot and intensely reactive.
Modern plants recover water while concentrating the iron for the next stage.
The pellets are fired until they become hard enough for the harsh blast furnace environment. Prepared raw materials are now charged into the blast furnace in controlled layers. Blending helps the plant turn a variable mine into a stable industrial feed source. The hot metal is loaded into insulated vessels that carry it across the mill. A controlled burn fuses the fine particles into larger pieces and the furnace can breathe through.
Before refining, the blast furnace slag is separated from the liquid iron.
At the steelworks, raw materials are unloaded and routed into enormous storage systems.
Before entering the converter, the hot metal is cleaned to remove sulfur.
Blast furnace iron is poured into the converter to begin modern steelmaking. The flux has to be sized just as carefully as the ore and coke. At the bottom of the furnace, molten iron gathers beneath a protective slag layer. Magnetic separation upgrades the ore by pulling iron minerals away from waste. Like ore pellets, coke must be sized carefully for efficient furnace performance. The concentrate leaves the wet circuit as a heavy, iron-rich filter cake. Only properly sized pellets move forward because furnace permeability depends on consistency. Steel scrap is added first to help cool and balance the converter heat. Pure oxygen burns out excess carbon and other unwanted elements in minutes. Argon stirring blends the steel and helps clean it from within. Mid-blow checks tell the operators when the chemistry is approaching the target steel grade. The furnace releases its product as streams of molten iron and slag.
Some steels go under vacuum, so hydrogen and other gases can be removed.
Fine ore is reclaimed from the yard and sent to become sinter for the blast furnace. The hot blast ignites coke and drives the reactions that turn ore into iron. When the chemistry is right, the converter pours liquid steel into a ladle. As hot gases rise, they remove oxygen from the ore and leave behind metallic iron. The oxygen lance moves into place above the molten bath. The strand follows a curved path, then straightens as solid steel. A tundish sits between ladle and mold to control and stabilize the casting flow. Inside the mold, the outer shell freezes first, while the center stays molten. The finished liquid steel now heads to continuous casting. Secondary refining gives operators one more chance to perfect the steel.
Powerful water jets remove scale so it will not be rolled into the surface.
Before rolling, the slabs are reheated to a uniform hot working temperature. Before coking, the coal is washed to remove impurities and improve furnace performance. Every slab gets an identity that follows it through the rest of the mill. The yard balances supply and demand, so the iron-making line never has to stop. At this stage, every degree and every alloy addition matters. Cooling sprays thicken the shell so the strand can hold its shape. With pelletizing complete, iron ore is finally ready for the steel plant. Limestone joins the process as the flux that will help clean the metal. Pelletizing turns fine concentrate into uniform balls, ready for high-temperature hardening. Alloy additions during tapping help turn generic steel into a specific product grade. Before shipping, the steel is tested to confirm it meets exact grade requirements. A light final pass fine-tunes the strip's flatness and surface feel. Every coil is checked for shape, dimensions, and surface condition. Cooling and finishing lock the protective coating into a sale-ready surface.
After rolling, the strip is wound into a compact hot-rolled coil.
The coil can also be turned into flat sheet, ready for fabrication. The finishing mill sets the strip's final gauge with extreme speed and precision. Automated inspection systems give every foot of strip a final quality check.
Wide coils are cut into narrower products based on customer needs.
What the furnace removes as slag can still become valuable industrial material. From raw ore to finished coil, the entire steel chain is managed in real time.
From iron ore in the ground to the backbone of modern life, this is how steel is made.
Roughing stands begin the massive reduction from slab to strip. After cold rolling hardens the steel, annealing gives it back the ability to form. The finished steel is packaged to survive handling, storage, and long-distance shipping.
Cold rolling makes the strip thinner, smoother, and more dimensionally precise.
Controlled cooling helps give the steel its final properties. The strip's ends are trimmed so the finishing mill can run cleanly and accurately. An endless cast strand is cut into slabs sized for the rolling mill. For corrosion resistance, many steel grades are coated with molten zinc.
Pickling removes the remaining scale and exposes clean steel underneath.
Air knives meter the zinc coating to a tightly controlled thickness. One destination for modern sheet steel is the automotive press shop.